Good morning, my dear Prep 1 students. Hope you are all fine today. In today's lesson, we are going to finish the last part in Unit 1, which is application on rational numbers. It's so easy, just few rules that we need to study by heart and apply to solve the question. So let's go now and begin our lesson. The distance between two numbers. How can I find the distance between two numbers? Simply, to find the distance between number x and number y, it's the absolute value of x minus y or absolute value of y minus x, where absolute value of x minus y is equal to absolute value of y minus x. So to find the distance between any two numbers, simply do the absolute value of the subtraction or the difference between those two numbers. Let's go now and have an example. Find the distance between half and 1 over 4. We said that the distance between any two numbers is the absolute value of the difference between them. So, absolute value of half minus 1 over 4. Remember, when we are adding or subtracting rational numbers, we must have the same denominator, and here we have different denominators. So, the most easy way to do it is to do it using cross multiplication. 2 times 4, and then this is my new denominator, which is 8. 4 times 1 and 2 times 1. Now I will have the absolute value of 4 minus 2 over 8, which is the absolute value of 2 over 8. To put it in the simplest form, it's equal to the absolute value of 1 over 4, which is, we said that an absolute value of any positive number is the same number. So it's equal to 1 over 4. So the distance between half and 1 over 4 is 1 over 4 units. Let's go now to have another example. Find the distance between negative 6 over 5 and negative 7 over 6. We said that the distance between any two numbers is simply having the absolute value of the difference between them. So, negative 6 over 5 minus negative 7 over 6. I have here different denominators, so simply 5 times 6, and this is equal to 30, and this is going to be my new denominator, and 6 times negative 6, which is equal to negative 36, and don't forget that I have here minus and a negative number. Minus and a negative number is changed to be positive. So 5 times 7, it's equal to 35. Now the distance is equal to absolute value of negative 1 over 30. And we said before that an absolute value of any negative number is the same number but positive. So, the distance between negative 6 over 5 and negative 7 over 6 is 1 over 30. The type of questions that comes here is that he come and ask about the number that lies half the way between two numbers, or 1/3 of the way between two numbers, 1/4 of the way, 1/5 of the way, and so on. There are some rules that we use to find this number. Let's go and see. The number that lies half the way is equal to the smallest number, so I must decide first what is the smallest number, plus half times the distance. And we said that the distance is the absolute value of the difference between the two numbers. And to find the number that's halfway from the greatest number is the greatest number minus half times the distance. What about if he is asking me to find the number which lies 1/3 of the way? The number which lies 1/3 of the way, he must decide either it is from the smallest or the greatest, as required. If he told me that he wants to find the number that lies 1/3 of the way from the smallest side, so the smallest number plus 1 over 3 times the distance. And we said again that the distance is the difference between the two numbers inside of the absolute value. And if he asks me to find the number that lies 1/3 of the way from the greatest side, so greatest number minus 1 over 3 times the distance between them. What about 1/4 of the way? If 1/4 of the way from the smallest number, then the smallest number plus 1 over 4 times the distance between them. And if from the greatest side, so the greatest number minus 1 over 4 times the distance between them. As you can see, they are all the same equations. We only change half, 1/3, and 1 over 4. What about, for example, if he asked me to find the number that lies 1/5 of the way from the smallest side. So the smallest number plus 1 over 5 times the distance between them. And the same goes for the greatest side. Greatest number minus 1 over 5 times the distance between them. Let's go now and have some examples on those rules. I would like you to open your binder, page 12. I am going to answer question number 1, 1 and 2, and 3 and 4 you are going to have as homework. So let's begin now. Find the rational number lying half the way between 3 over 8 and 5 over 8. So let's begin. To be able to solve those types of questions, simply, the first thing we should do is to find the distance. And we know that the distance between any two numbers is the absolute value of the difference between them. And the second thing we should do is to find which number is greater and which number is smaller. So let's go now and begin. The first thing we should do is to find the distance between the two numbers. Distance between the two numbers is the absolute value of the difference between them. So absolute value 3 over 8 minus 5 over 8. As you can see, I have the same denominator. So I can go and subtract the rational numbers. It's equals to 3 minus 5 over 8, which is equals to absolute value of negative 2 over 8. And we said that an absolute value of any negative number is the same number but in positive. So it's equal to 2 over 8. Now I have known the distance. Let's go now and see which number is greater and which number is smaller. As we can see here, 3 over 8 and 5 over 8. So 3 over 8 is less than 5 over 8. 3 over 8 is the smallest number and 5 over 8 is the greatest number. So if I want to find the number that lies half the way from the smallest side, I'm going to use 3 over 8. So this rational number is 3 over 8, which is the smallest number, plus, open a bracket, half times the distance that I have already calculated to be 2 over 8. We know that whenever in mathematics we find a bracket, we go and solve it first. So 3 over 8 plus 1 over 8. This is the result of multiplying half times 2 over 8 in the simplest form. So this rational number which lies half the way from the smallest side is equal to half. The question is, do you think if I make it from the greatest side, the rational number is going to differ? This number lying half the way? Of course not, because it's in the middle. It doesn't differ from the middle, from the greatest side or the smallest side. But let's do it to make it more clear. The number that lies half the way from the greatest side is equal to the greatest number, which I know it's 5 over 8, minus half times the distance, which I calculated to be 2 over 8. So, it's equals to 5 over 8 minus half times 2 over 8. Again, when I see a bracket in mathematics, I go and solve it first. So 5 over 8 minus 1 over 8, having the same denominator, so it's easy to find the difference. And it's equals to half. As you can see, the number which lies half the way from the smallest side is the same as the number that lies half the way from the greatest side. It doesn't differ. So in the exam, it's your choice to use any one of them, unless he has decided which one you should choose. Let's go now to question number 2. Negative 4, 3 over 7, and 1 over 3. We said that to solve those types of questions, the most important thing is, first of all, to find the distance between the two numbers, and then define which number is greater and which number is smaller. So, it's obvious that any negative number is smaller than any positive number. So I know that negative 4, 3 over 7 is smaller than h1 over 3. The first step we should do is to find the distance between the two numbers. And the distance between any two numbers is the absolute value of their difference. So, absolute value of negative 4, 3 over 7 minus h1 over 3. We have here a mixed number. So first we should go and change it to be an improper fraction. So it's an absolute value of negative 31 over 7 minus 25 over 3. As you can see here, we have different denominators. What should we do? Simply, to be able to subtract two rational numbers, they must have the same denominator. So the most easy way to use is cross multiplication. 7 times 3, and this equals to 21. And then 3 times negative 31, which is negative 93. And the operation, which is subtraction, I will move it as it is. 7 times 25 is equal to 175. So I have now negative 268 over 21 inside of the absolute value. So absolute value of any negative number is the same number but positive. 268 over 21, and this is the distance between the two numbers. Let's go now and find the number that lies half the way from the smallest side. We know that the smallest number is negative 43 over 7, and the distance I have already calculated to be 268 over 21. So it's easy to substitute in the rule. So the rational number lying half the way from the smallest side is equal to the smallest number, which is negative 93 over 21, plus half time the distance, which is 268 over 21. Doing the bracket first, so negative 93 over 21 plus 134 over 21. Having the same denominator, it's easy to find the addition of those two rational numbers. It's equals to 41 over 21 in the simplest form. So 41 over 21 is the rational number that lies half the way between the two numbers. And it is the same if I want to find it from the greatest side, but here I am going to use the greatest number minus half times the distance. I know that the greatest number is 81 over 3, which when I change it to be an improper fraction, it was equal to 175 over 21 minus half times 268 over 21. Having the answer of the bracket first, 175 over 21 minus 134 over 21. Again, I have here the same denominator, so it's easy to go and find the answer of the subtraction of those two rational numbers. It's equal again to 41 over 21 in the simplest form. And as you can see, from the smallest side and from the greatest side, I have the same number. Why? Because I'm looking for the number exactly in the middle, so it doesn't differ from the smallest side or from the greatest side. You will have now number 3 and number 4 as homework. And let's go to question number 4 in page 12 in the binder as well. I'm going to solve the first question, and you will have 2 and 3 as homework. Question number 4 is asking me to find the rational number that lies at 1/4 of the way between 5 over 7 and negative 3 over 7. So I am looking for the number that lies 1/4 of the way. Since it's not half, he must decide to me whether he wanted from the smallest side or from the greatest side. And in this question he didn't determine, so I am going to make both of them. And in the homework you're also going to make both of them. In the exam, if he didn't say he wanted from the smallest side or the greatest side, so you must make it for both of them. Let's go now and see. We said that to solve those questions, first, we must determine which number is greatest and which number is smallest. It's easy to know that any negative number is smaller than any positive number. So negative 3 over 7 is smaller than 5 over 7, and that's obvious. The second step we should do is to go and calculate the distance between the two numbers. We said that the distance between any two numbers is the absolute value of the difference. So 5 over 7 minus negative 3 over 7, and this is equals to 8 over 7. Now I know the distance, and I know the smallest number, and I know the greatest number. So let's go and see the rule. The rational number which lies 1/4 of the way from the smallest number is equal to the smallest number plus 1 over 4 times the distance between them. I already know the smallest number, and I know the distance, so let's go and substitute in the rule. It's equals to negative 3 over 7 plus 1 over 4 times 8 over 7. Again, do the brackets first, and it's negative 3 over 7 plus 2 over 7, which is equals to negative 1 over 7. So the number that lies 1/4 away from the smallest number is negative 1 over 7. What about from the greatest side? So I am going to use that from the greatest side, the greatest number minus 1 over 4 times the distance between them. I know that the greatest number is 5 over 7 minus 1 over 4 times the distance, which I have already calculated to be 8 over 7. So it's equal to 5 over 7 minus 2 over 7, which is equals to 3 over 7. The number that lies 1/4 away from the greatest side is equal to 3 over 7. You will have question number 2 and 3 as homework, but don't forget that you should make it from the smallest side and from the greatest side. Let's go now and summarize what we have said. To find the number that lies half away, third of the way, fourth of the way, and so on, the first step we should do is to find the distance between the two numbers. And how can we find the distance between the two numbers? Simply, it's equal to the absolute value of the difference between them. And it doesn't matter if I do x minus y or y minus x. At the end, both of them are equal. And the second step I should do is knowing which number is greatest and which number is smallest. Now, let's go and see the rules. To find the number which lies half away from the smallest side, it is the smallest number plus half times the distance between them. And from the greatest side, greatest number minus half times the distance between them. And we agreed that the number will not differ from the smallest or from the greatest side when I am looking only for half the way. But if I am looking for third away, fourth away, or fifth away, he must determine he wants it from the smallest side or from the greatest side. If you want it from the smallest side, then the smallest number plus 1 over 3 times the distance between them. And if you want it from the greatest side, so greatest number minus 1 over 3 times the distance between them. And the same goes for the fourth. I am only going to change 1 over 3 to be 1 over 4. By now, Prep 1, we have finished today's lesson. I would like to thank you all and have a nice and awesome day.